Yes, Steward, good morning. Steward, good morning. Yes, Steward, good morning. Okot Steward, good morning. Semanda, good morning. Semanda, I'm not hearing from you. Good morning. You can unmute yourself and then say something. You people, are you getting me? Are you hearing whatever I'm saying? Members, are you hearing me? Hello? Hello, hello, members, are you hearing me? Semanda, unmute yourself. I want to hear from you. Hello, hello, Semanda, unmute yourself. I want to hear from you. You're not saying anything. Hello? Okot Steward, good morning. People, you need to unmute yourself so that you can hear me. I'm not hearing you. Hello, 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 members. Where is the problem, you people? You're not speaking, you're not hearing me, I'm not hearing you. Where is the problem? Hello? Hello, 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 members. I'm not hearing you, but I'm speaking, but you're not hearing me. Don't see any reply from you. Are you getting me?
Yes, we are getting you.
Yes, Friday, you're getting me, but others are not replying. I don't know where the issue is.
I'm getting you.
I also need to hear from the others before I begin the lesson. Others are not responding. Okot, yes, I see your video, but you're not responding. You need to unmute yourself and then say something. Steward. Okot Steward, you're not saying anything. I'm seeing only your video. I think what you can do is to allow headphone. There is an option of allowing headphone so that you can speak, or you unmute yourself. Because I think you're hearing me, but then you cannot respond, or I can't hear from you. I see about 5 people who have already joined in. I see Friday, I see Semanda, I see Okot, but only Friday is responding. I don't know what's the problem to the rest. You need to unmute yourselves, or there's that option of allow headphone. You allow join in with audio. Somewhere they tell you to join in with audio. That's the only way you can speak. If you can't speak, then there is that option of chat. You go to the chat, you type a message. I'll be getting the message and replying to you. Then to avoid being on and off, you need to get a stable internet connection. Semand, are you hearing me? Are you hearing me by audio on the Zoom lesson? Because I'm not hearing from you. I'm speaking, but I'm not seeing your response. Members, are you getting me very well? Hello?
Yes.
Oh, Friday, it seems you're getting me clearly. Semanda, Darius, Benjamin is not getting me. Darius, good morning. Yes, Darius, good morning. Benjamin, good morning. Good morning, Benjamin. Oh, you people. I don't know where the issue is. I don't know where the issue is. I can't go on with a lesson when I'm not hearing from you. I don't know where the issue is. Stuart, good morning. Hello, Stuart, good morning. Benjamin, good morning.
Good morning.
Yeah, at least now 2 people are getting me. Friday, are you still on?
Yeah, I'm on.
Semand, are you getting me? Okot Stewart, are you getting me? Are you hearing me? Stewart, are you hearing me? Let me see the chat here and then try to get you by chat. Special What's happening? What's happening? What's happening? You need to unmute yourselves. You need to unmute yourselves when speaking. Or
because of the situation around, but
yes, Lawrence, are you getting me? Lawrence, are you hearing me? These people are not hearing me. I don't know what their problem is. The rest are not hearing me. I don't know where the problem is with them. But
I'm getting.
can we go with the lesson members? Okot, are you hearing me?
No.
Okot,
They should activate their audio.
Yeah, they haven't connected their audios. I think that's the only problem hindering them. Friday is hearing me. Benjamin is hearing me. Semanda is not hearing me.
you can also look at the available. And
For now, this is Darius hearing. Benjamin, I'm also getting you.
Okay, Darius is hearing me. Friday is getting me. Semanda and Okot, you're the people who haven't allowed audios on. Semanda, allow your audios on.
It's a challenge to tell students to comply to SOP. Not on the students, they've seen in many countries, many people around. But first of all, we are lucky that we still have manageable numbers. National Council of Higher Education approved and accredited 50 students for medicine, 15 students for faculty for surgery, 75 students for EIT, 150 students for business. Business and IT are scheduled to study every weekend.
Okot, are you now getting me?
We have medicine and dentistry studying during the day, throughout the week. So we have divided our students into manageable numbers, and the facilities that we have can take just small numbers. But that
someone who has backup round. Darius or Benjamin, there is some TV that it makes
it is now switched off.
Okay.
It was Darius.
Yeah. I think those people who muted their audios, they can hear, though we cannot hear from them.
Okay, Okot, are you hearing now? Okot, please say something. Are you hearing then? Now. And are you now hearing? Oh, this is a bit small.
No, Semanda is hearing, but the problem cannot give us the feedback because the audio is muted.
How about Okot? Okot, are you hearing us? So anyone who cannot give feedback by talking, what you do is to go in the chat box and type a message. You can type a question or type a message there. I will be reading it and responding to you. Allow me begin the lesson now, because you may not wait for all of other people to join.
But I think it's very easy, okay? Let them go the bottom left, then they click join audio.
Yeah, that's a better option.
Somewhere down there from the bottom left, they connect join audio, then they select data or Wi-Fi.
Do that.
Thank you, Lauren, for the guidance. I want to share something that we are going to be using for this lesson.
Right where?
I want to open the document that we shall be using for this lesson specifically. That document is, we are looking at thermochemistry, as I earlier told you. For those who tried to see the messages I sent. I'll be using PowerPoint for today. I'll be using a slideshow. I'm now sharing my screen with you so that you can see what we are going to be covering today. Yeah, it is. Is everybody able to see his screen now? Whatever we are dealing with.
Yeah.
All right. I want to zoom this to be a bit bigger so that yeah, I think this is now a better option. So we are here for thermochemistry as our topic, and I'm Joseph Jobs Kayiira to be taking you through this topic. Thermochemistry is concerned with heat, but with some reactions, heats of reactions. That's what we shall be basically looking at. My WhatsApp number is, you can note it down in case you want to consult me further. It's 0782, no, the WhatsApp is 0753 2470 98. 0753 2470 98. And then the other contact is MTN, that is not on WhatsApp, but you can still contact me using it. That is 0782 6010 38. So you see something like fire here showing that the topic we are here to look at is concerning fire. Thermochemistry deals with energy changes that accompany chemical reactions. Sometimes you can call it chemical energetics or chemical thermodynamics. That's the other name we normally give it. Okay? You can call it chemical kinetics, or I mean, can call it dynamics. What does this topic investigate? What is it mainly concerned about? This topic is mainly concerned about, or it investigates the position of an equilibrium of a chemical reaction, feasibility of a reaction, whether a reaction can take place or it cannot take place. That's what we call feasibility. Feasibility is determining whether a chemical reaction can take place or cannot take place. Yeah. Oh, it tells you you can't unmute yourself. That is Semanda. or let me allow you to unmute yourself. Let me allow you to unmute yourself so that you can be able to comment. But there is somewhere people can unmute themselves. Yeah, like Darius is unmute, even Galaxy S8 is unmute. So you can unmute yourself. I don't know why it's giving you that option for yourself. Thermochemistry investigates the position of equilibrium in a chemical reaction. It also investigates the feasibility of a chemical reaction, and it determines how far the reaction can do what? Can proceed. So in case you have a challenge up to now, you can still ask a question. We are proceeding. This topic has something called chemical energy in it. And when you talk of chemical energy, we must know what energy is. In your O-level physics, you looked at what energy is, and it's not a new thing to you. Energy is capacity to do work. If you can do work, then you have energy. Now, chemical substances also have capacity to do work, which we normally call the Gibbs free energy. So chemical substances, any chemical has a capacity to do work, and it therefore possesses what we call chemical energy. That chemical energy must be converted from one form of energy to another one. And the form of energy to which chemical energy is converted is what we call heat energy. In this topic, we shall be more interested in this heat energy that I'm talking about here. All right. If you have no issues up to now, allow me proceed. Transfer of energy in compounds involves change in motion of atoms or molecules. And energy is always transferred from regions of high temperature to regions of low temperature. That's what usually happens. There's transfer of energy from regions of high temperature to regions of low temperature. And the heat developed by a chemical substance can be used as a measure of chemical energy liberated. Change in chemical energy of a chemical substance is only measured if the substance is treated in a certain way. So in chemical thermodynamics or thermodynamics of heat, we shall be needing to burn a substance. Then we see how much energy it evolves, and then use that energy as a measure of its enthalpy of combustion or enthalpy of formation. Yes, sorry for the interruption, but I'm saying that the change in chemical energy of any chemical substance is measured only if the substance is treated in a certain way. For example, we can burn it in oxygen. If we are burning maybe a polythene bag in oxygen, polythene is just a polymer of carbon, a compound containing carbon and hydrogen. So when you burn polyethylene, it produces carbon dioxide, water, and heat. That heat evolved can be used as a measure of the chemical energy polyethylene contains. Are you following? So that we proceed. That's fine. So that's how far we have gone. Is there any question so far? Does anybody have a question up to that point? You know, when I'm speaking and I don't hear from you, sometimes it may not be good. Are you hearing from me, and do you have any concerns so far up to this point?
We are hearing, and you, I don't know.
Okay, Okot is now hearing. That's nice. We may proceed. So what happens during a chemical reaction? Chiche tuita chemical reaction, and what happens during a reaction? During any chemical reaction, there is bond breaking and bond formation. So bonds are broken. We may call them old bonds as new bonds are formed. So when new bonds are formed, that means there are products being formed. And what happens during a breakage of bonds? During breakage of bonds, energy is absorbed. So if any bond is to break, energy must be absorbed. I know most of you here are males and you have girlfriends. If you're to lose those girlfriends, then the bond between you and the girlfriend must be broken. And you know how you normally break those bonds. You either break the bonds by maybe getting another girlfriend or stopping communicating to them or any other options. But the moment the bonds are broken, that means you're yet to form new bonds. You're yet to get new catches. Yeah. So energy must be absorbed. There should be something that happens to break the old bond as you're forming the new bonds. I hope that's very clear to you now. So what you should basically understand is that during chemical reactions, old bonds are broken as new bonds are formed. We may now proceed to the next slide. In this next slide, I'm looking at what we call heat content of a substance. Okay. You know, when you love a girl or when you love a boy, I don't see any female here. There is something you like in them. There is something you like in them. That's what they have to offer on table. So if it's a chemical compound, then that becomes the heat content of that compound. Chicherimu, what does it contain? What energy does it contain? So that's what we call heat content of a substance. So every chemical substance known has some energy stored in it, chemical energy stored in it. So every substance has some chemical energy, and the heat content contained by those substances differ from one substance to another. For example, charcoal, if you're to compare charcoal with paraffin, one of the two must have more energy content than the other. Okay? If you have gas and you're using gas to cook and maybe somebody's using charcoal, there is one of the two has more chemical energy. And that's obviously gas. That's why gas cooks faster than any other substance. So you need to know that heat content differs from one substance to another. Reason being that the molecules of different substances define number and type of atoms and even the type of bonds in them. Some compounds have triple bonds, others have double bonds, and others have multiple bonds. So there should be a variation in heat content of the substance. Mind you, these notes will be sent to people who have subscribed. There are about 3 people here who subscribed. This lesson was made free, but I'll be sending notes only those who subscribed to these lessons by payment of monthly fees. In case you need to consult me about the payment, mode of payment, and the over attending lessons, my number is 0782 60 10 38. That is MTN. And then the Airtel is on WhatsApp. That is 0753 24 70 98. All right. I do now proceed to the next slide. We at all level used this term enthalpy, which I'm now calling heat. Enthalpy or heat of reaction shouldn't be a new term to you that confuses you. Enthalpy is the energy content of a substance. Simply that. And we normally give it a symbol capital H. It's the energy content of a substance. It's normally given a symbol capital H. So that's something we should be acquainted with. What is enthalpy change? We have known enthalpy as heat change of heat content of a substance. How about when we add the word change on it to make it enthalpy change. Enthalpy change of a substance is the heat change of a substance measured at standard temperature and pressure during a chemical reaction. Heat change of a substance measured at standard temperature. Standard temperature is normally 25 degrees Celsius, and then standard pressure is normally 1 atmosphere during a chemical reaction. So enthalpy change is the heat of reaction and is denoted by this symbol. Delta normally is used to mean change. So on the heat, which we decide heat content is called the H, we simply add the symbol delta to now make it heat change. All right. Friday, are you still hearing me?
Yes, I'm getting you.
How about Benjamin or Akubariho?
Yes, I'm getting you.
Then Semanda, are you getting me? Semanda can't respond. Semanda, you need to unmute yourself. There is that option of unmute yourself when you're responding. I've asked you to unmute, but you're not doing so. How about Okot? Are you getting me? I hope these people are getting me. The only problem is that they can't respond. All right. I do proceed to the next slide. We now come to the real chemistry of this topic. What is standard enthalpy of a reaction? Standard enthalpy change, which is now delta H theta. This is the enthalpy change when a reaction takes place, such that the reactants react in their standard states, as shown in an equation of reaction at 1 atmosphere and 298 Kelvin. So this word is standard here. Whenever you say word is standard, then you think of these two conditions, 1 atmosphere and 298 Kelvin. So it's the enthalpy change. Standard enthalpy change is the enthalpy change that takes place when the reactants react in their standard states. For example, if I'm forming carbon dioxide, I'll have to react carbon and oxygen. Carbon must be in its standard state of a solid. Carbon is known to be a solid. And then the oxygen must be in its standard state as a gas. Okay? If I use the carbon in a gaseous form, you don't know that, but it's true that any substance can be made gaseous, solid, or liquid. So if I instead use the carbon in gaseous form, then that's not standard enthalpy change. If I use the oxygen in liquid form, then it ceases to be standard enthalpy change. So when the word standard is added there, then the definition changes. The enthalpy change when a reaction takes place, as the reactants react in their standard states, as shown in the equation for the reaction at 1 atmosphere and 298 Kelvin. Then the standard state of a substance is the phase. Note this word very carefully. They can ask you to define standard enthalpy change. They can ask you to define standard state of a substance. So standard state of a substance is the phase in which a pure substance exists at 1 atmosphere and 298 Kelvin. Is the phase in which a substance exists in its standard state, in its pure phase. Phase is somehow similar to state of matter, but we don't normally use state of matter. We instead use phase, which is the phase in which a substance exists at 1 atmosphere and 298 Kelvin. I'm delaying so that I give you time to read through and follow. So the units for standard enthalpy of reaction are always given as kilojoules per mole. They are given as kilojoules per mole, as you see in that slide.
Excuse me, sir.
Yes, you can ask.
I've not got you clearly.
Mm.
This is Benjamin.
Yes, I'm getting you, Benjamin.
You've said what is the condition for it to be standard enthalpy change on that explanation? I never got you.
For an enthalpy change to be standard, that enthalpy change must occur at 1 atmosphere and 298 Kelvin. If that confuses, you can simply say at standard temperature and pressure. Is that now clear, Benjamin?
Then another thing I heard you talking about a standard substance that maybe some substances can be changed in different states, like aqueous. On that, I don't know what you are explaining.
So I told you, I'm telling you that, for example, if I'm reacting carbon and oxygen form carbon dioxide, if I use the carbon in its gaseous state, I've told you carbon can exist in a gaseous state, right? So if I use the carbon in its gaseous state and the oxygen in its liquid state, oxygen can be liquefied. I can still form carbon dioxide, right?
Yeah.
But that won't be standard. The heat evolved in that case won't be standard enthalpy change. It will instead be enthalpy change. It only becomes standard if those substances are in their standard states, which I have defined it down here, and when the reaction is occurring at standard conditions. Am I now clear, Benjamin?
Yeah, you're clear. I've got you.
All right. More of these notes are provided in our books, which you can still contact me. They can be delivered countrywide. Demystifying Physical Chemistry, authored by me, and Demystifying Inorganic Chemistry, still authored by me. All right. We can now proceed to the next slide, if this is very clear. What are the types of heats of reactions? There are normally 2 types of heats of reactions, and these are determined depending on the enthalpy change that occurs. Is there heat absorbed or heat given out? When heat is absorbed, the enthalpy is called, the heat of reaction is called endothermic. Endo means in. Enthalpy is heat is absorbed, or temperature is decreased. Okay, so enthalpy, heat is absorbed. If the reaction is exothermic, then heat is given out. Is that also clear? If it's clear, please allow me proceed. Can I hear from you?
Yes, it is clear.
All right. Just giving you a minute to observe that clearly.
You've said for exothermic, what happens?
For exothermic, heat is given out, right? It is given out, and that means the temperature must decrease. I'm going to show you the enthalpy, the graphs that are defining these elaborately. Look at this. Look at the differences here. Is everybody seeing his screen? Are you seeing your screens?
Yes, sir, we're seeing.
Yeah, we are giving differences between exothermic and endothermic reactions. Whereas exothermic reactions proceed with evolution of heat to the surroundings, endothermic reactions proceed with absorption of heat from the surroundings. And that means that for the exothermic reactions, the products are at lower energy level than reactants. What do we mean by this? Since energy is given out, products are less activated. They are at a low energy level than the reactants. Okay. Whereas in endothermic, the products are at a higher energy level than the reactants. Look at these 2 equations carefully. They will show you what we mean. In this reaction, hydrogen gas is reacting with iodine gas to form hydrogen iodide. And in this case, this negative implies that heat is given out. Okay, negative means heat is given out. So that is an exothermic reaction. In this case, we are reacting solid carbon and water in its steam form. We are reacting with gaseous water, so that's steam, form carbon monoxide and hydrogen. In this case, heat is absorbed. That's why you see a positive charge here. So the positive charge indicates that heat is absorbed for this reaction. Are we together?
Yes, we are together.
So if we are together, then you can very well, I'm always giving you time to observe this clearly so that you can be able to follow through for those who don't have the notes. As I've told you that you will kindly allow me send notes to only people who subscribed to these lessons. So in the first reaction, you see that 1 mole of hydrogen reacts with 1 mole of gaseous iodine to form 2 moles of hydrogen iodide. In the second case, you see that 1 mole of carbon, this is 1 mole of carbon reacting with 1 mole of steam to form 1 mole of carbon monoxide and 1 mole of hydrogen. This mixture is what we call water gas. I mean synthesis gas with absorption of that amount of heat. So if that's very clear, you can allow me proceed. I don't want to delay your time. We are continuing that the enthalpy of reaction is an indicator of its feasibility. The more negative or the more exothermic the enthalpy of reaction, the more negative or more exothermic the enthalpy of reaction, the more likely it is to be feasible. Hey, haven't I gone so far? Not yet. I think this is a point that we should give more interest or explain in detail. Whenever the enthalpy of reaction is more negative, more exothermic, then that reaction is likely to be feasible. In other words, the reaction is likely to proceed or to easily occur. Okay? And the moment the reaction is, the enthalpy of reaction is more positive or more endothermic, then that reaction does not easily occur because it needs a lot of heat to be absorbed. Are we together, members? Friday, are we together?
Yes, we're together.
Right. These are energy level diagrams for exothermic and endothermic reactions. So exothermic and endothermic reactions. Look at the two carefully. But before going into the details, we need to know what an energy level diagram is. I can ask you to define what an energy level diagram is. An energy level diagram is a graph of potential energy. It's a graph of potential energy of a reaction against the reaction coordinate. A graph of potential energy of a reaction in kilojoules per mole against the reaction coordinate is what you call an energy level diagram. This is for an exothermic reaction, which we have already seen. We have already seen in our previous reaction that that when hydrogen reacts with iodine, form hydrogen iodide, heat is evolved. It's a negative enthalpy change. So when hydrogen, as you're seeing here, when hydrogen reacts with iodine, form hydrogen iodide, heat is given out. That's why you see that the products are at a lower energy level than the reactants. That's a characteristic of an exothermic reaction. The products are always at a lower energy level than the reactants. Now, the difference between energy, we shall see that later. It's another definition of enthalpy of reaction. The difference between energy content of the reactants and energy content of the products is called enthalpy of a reaction. Difference between energy content of the reactants and energy content of the products at standard temperature and pressure is called the standard enthalpy of reaction. And then difference between energy of the reactants and energy at the activated complex is what we call the activation energy of the forward reaction, EA. Then the difference between energy content of the products and the activation energy is what we call activation energy of the backward reaction. Is that clearly understood?
No, sir.
I know it may be a bit disturbing, but we shall be able to get it later on. Are we still following? Are we following?
Yeah, we are following.
Yeah, we are following.
Okay.
But I think he has to look at those diagrams clearly to get the difference, because you are explaining clearly. When you look at the difference, you'd easily get them, because he was like the difference between the, unfortunately, I don't have the cursor, I would have explained for you. He was talking about the activity backward for the backward reaction and forward reaction, and the standard enthalpy of reaction. All those ones, I think you were clear, but you can repeat for him also.
All right. Thank you for.
Okay, thank you, man.
Thank you for elaborating for him. Let's look at an endothermic reaction. What happens for an endothermic reaction? For an endothermic reaction, the products are at a higher energy level than the reactants. Why? Because heat is absorbed. So when heat is absorbed, the products now will have a higher activation energy or a higher energy content than the what? Than the reactant. So they will be at a higher energy level because temperature is increased. So I want you to get it in that way. If temperature is increased, that means that heat is absorbed, such that now the reactants, the products at a higher energy level than the reactants. The explanation is the same for these differences here. The difference between energy content of the products and energy content of the reactants at standard temperature is what we call the standard enthalpy of the reaction. So you'll get them better if you attempt questions. At the end of this, we shall be having some questions to attempt. Don't worry, these things are understood after reading them in detail when you are alone. Is this screen able to seen by everybody now? Is everybody seeing where we are now? So EA is the activation energy for the reaction. It's normally given that notation, but we can as well call it activation energy of forward reaction. So activation energy can sometimes be called activation energy of forward reaction. This difference here, difference between energy content of reactants and the activated complex. Energy content of reactants and the activated complex, what we call the activation energy. EB is the activation energy of the backward reaction. We can be able to see it here. Backward reaction. Difference between energy content of the products and activated complex. Difference between energy content of the products and activated complex is what we call the activation energy of backward reaction, or EB. So there is always delta H theta is what we call the activation I mean the enthalpy of reaction. Okay. Then we need to define what activation energy is. It's the minimum energy which is required to be possessed by reactants in order to react to form products. Okay. Friday, can you define Mrera Manzi Stencilus? Can you try to define for us what activation energy is? Yes, Mrera Manzi, I see you have unmuted yourself. You now speak. You can now speak. What's activation energy? Oh, sorry, Mrera Manzi's network is not good. It's breaking. Yes, Darius, what is activation energy?
We are not hearing from him.
He has a problem of network.
Yeah.
Friday, you can read for us what activation energy is.
Is the minimum energy
Hello?
which is required to be possessed by reactants in order to react to form the products.
Very good. That's a very important.
So I also have a question here. Can you clarify for me, is there any difference or similarity between activation energy and bond energy?
Yes.
Okay. Activation energy is different from bond energy. Bond energy is energy required to break bonds, okay?
Bonds.
When bonds are broken, that's bond energy, right? But when we are talking about activation energy, the reactants must possess some energy. A reaction cannot take place unless reactants have possessed some energy. Just like a car cannot start unless the engine has been accelerated to a given level. Okay, you have seen cars that say choo, 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 then it stops, choo, 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 then it stops. That means the engine has not reached that maximum potential energy required for the car to start. That's a similar case for reactions. Unless the reactants have possessed enough energy, then a reaction cannot take place. The reactants must possess enough energy for them to react to form products. Are we together?
Yeah, I'm following.
All right. So the enthalpy change can be obtained using this expression. So enthalpy of a given reaction is given by activation energy minus activation energy of backward reaction. Enthalpy of a reaction is always given by the equation activation energy minus the activation energy of backward reaction. Let's look at a few examples here and see. I don't know what's happening with my, all right, here are some questions. Carefully look into a few questions that can be set to bring out the concepts I've talked about. And then maybe you can ask a question, or you may copy a few down that you may try out. Let me take you through question 2. We can define activation energy. Who can define for us activation energy in question 2? Once again.
Yes.
Yes, you can define activation energy, please.
Is the minimum energy which is required to be possessed by reactants in order to react to form products.
Very good. Then we have this part B here. X and Y react to form W and Z according to this equation. Is this reaction endothermic or exothermic?
It's endothermic.
Yeah, the reaction is endothermic.
Because the enthalpy change is positive.
Okay. So what will be at a higher energy level? Is it the reactants or the products?
The reactants.
The reactants will be at a higher energy level. Is that true? That's not true, my brother. Let's go back here. This is an
for endothermic reactions, I think the products are supposed to be at a higher energy level.
Very good. The products will be at a higher energy level because heat is absorbed. There's an increase in temperature, hence an increase in potential energy. That thing confuses so many students. So let's get it clearly. Have you understood it, members?
Yes.
Right. So the potential energy diagram will look like this one for that question 2 specifically. Then you must label it very well. You put this, you put this. Show the reactants, show the products, show the activated complex. These values, if you have them, show them in the table, in your sketch. Okay? Can I proceed?
Yes, you can.
Yes.
So there is that question here. Calculate the activation energy of the backward reaction. Who can try to do it in a very few minutes and tell us the answer? What would be the answer for the activation energy of the backward reaction?
Yes, I can try.
What's the answer? What answer do you get?
150.
Very good. You've been following. That's very good.
150 kilojoules per mole.
Very good, very good, very good. Someone can clap for you. You know, Zoom is very interesting. There's an option of clapping where you see, where you see what? Those who are new to Zoom, there's an option of reactions. So where you see reactions, you can clap, you can appreciate, and so on. So the rest of the questions will be tried by you in your free time. We proceed. Applications, we are talking about enthalpy of reactions, enthalpy of what, but where are they applied? Where is enthalpy applied? Enthalpy is applied in so many things. For example, for the exothermic reactions, they are applied in some reactions. For example, during football games, they are what we call hot packs and cold packs. Hot packs are normally those things you see. Here in Uganda, I've not seen them, but later ice. They bring ice, they bring water and power on somebody. Imagine, somebody has got an injury in a football match, then they power water on him, on his leg. They put their ice and then they tell him go back to the pitch. think that's laughable. So it's what we call a cold pack or a hot pack. For example, somebody can read for us this first option here, first use here. I'm also not seeing my screen very well, but somebody can read it for us. Anybody seeing the first application of exothermic reactions to read for us?
Yes, I'm seeing.
Yes, you can read it for us.
In hot packs, which are used to treat spots in and warming the body in case of coldness. The instant hot packs have separate compartments of water and anhydrous calcium chloride separated by a thin film placed in a plastic bag. When the bag is squeezed, the thin film breaks and the anhydrous calcium chloride dissolves in the water exothermically to release heat. Then we are having some equation below that.
So that's very good.
Calcium chloride.
So in what you call a hot
welcome.
pack, that thing you see they put on people's injuries in football matches or other games is normally either hot pack or cold pack. It depends on the injury somebody has. So if somebody is feeling very cold, they will use a hot pack. They put a hot pack on the wound and then squeeze it. When it's squeezed, there is a compartment that separates the water. I think to understand this very clearly, let me take you to another share. Alt Shift S. Here we are. I want to take you to another. My system is freezing. I want to take you to the internet and you see what a hot pack or cold pack looks like. But it seems there will be a delay for me, which I don't want to waste. I don't want to waste time with it here. That one will delay us so much. I'm not going into it, but you can try in your free time and search what a hot pack is or what a cold pack is. Be able to see it.
Yeah, we are going to do it.
Be able to see it by the internet. So this is the reaction that takes place. The calcium chloride or any other anhydrous salt reacts to the water and it involves some heat. The enthalpy change that occurs there is called the enthalpy of hydration, or enthalpy of, it's actually enthalpy of solution. These two other salts here can be used instead of calcium chloride. Exothermic reactions can also be used in combustion of fuels to release energy during cooking of food, even in engines, diesel engines and petrol engines. In cellular respiration, it has some biology. Energy is obtained from carbohydrates and used by living organisms. So during that process, carbohydrates react with oxygen, form carbon dioxide, water, and energy. Then during condensation, formation of rain from water vapor. Water vapor usually condenses to form rain by an exothermic reaction by giving out heat. Then freezing of water into ice also involves an exothermic reaction. Heat is given out by the water. Heat must be lost, temperature must be lowered, so as ice is formed. Why do I have a blank screen here? I don't know why I have a blank screen here. Slide should go away. And this one. And this one. Yeah. So we are back to our screen share. We have very few minutes to the end of the lesson. There's somebody joining in called Rashdi Mangala. All right. We now look at applications of endothermic reactions, reactions that involve absorption of heat. Okay. Let's look at this first application here, the cold pack, which I've been talking about. This one now uses salts that dissolve endothermically by absorption of heat. So that instant coldness is provided to somebody who is feeling a lot of warmth where the injury part is. Okay. So can somebody read for us what how a cold pack works?
In instant cold packs, which are used to treat sports injuries, the instant cold packs have separate compartments of water and solid ammonium nitrate, separated by a thin film placed in a plastic bag, full stop. When the bag is squeezed, the thin film breaks and the solid ammonium nitrate dissolves in water endothermically to provide instant coldness. It is absorbed from the surrounding, such as the injured area of the athlete's body.
Very good. So what happens during a cold pack is that somebody is injured. Messi doesn't normally make injuries to people, but Ronaldo is more violent. Imagine if the other most violent player I remember in history is Balotelli. So if Balotelli injures Messi, and Messi can no longer stand and is feeling a lot of heat at the injured area, the physicians, the sports physicians will come with an instant cold pack. They put it on the wound. It has two compartments, one containing the salt, the other is water. When it's squeezed, the compartment breaks, and then the ammonium nitrate mixes with water. It absorbs the heat from the injured area, and then the person can feel instant coldness. He's relieved. You see him back to the pitch. I think that's very clear. Okay. Is that very clear, members? The other application of such reaction is photosynthesis. In photosynthesis, energy is absorbed to convert the carbon dioxide and water to sugars in presence of chlorophyll. So that's an application of an endothermic reaction, evaporation of liquid water and melting of ice. Which factors affect enthalpies of reactions? There are so many factors, but here are a few of them. The temperature at which the reaction is carried out, okay, may affect the enthalpy of reaction. The pressure of the gaseous reactants or products. So when you're talking about the factor of pressure, you must specify pressure only affects gaseous reactants or products. If the reactants are not gaseous, then the pressure is not a factor. When you ask the question to state factors that affect enthalpies of reactions, you must specify. If it comes to pressure, you specify that it's for gaseous reactants or products. Then if it comes to temperature, you must specify that it's the temperature at which the reaction is carried out. Then the other factor is the amount of reactants used. There are reactions where if the amounts of reactants used are very many, then If the amounts of reactants used are very many, then the reaction is very exothermic. If the reactants are very few, the amount, the reaction is very endothermic. So you need to know that. The last factor here, not the last one, but the next last, is the physical state of the reactants or products. And this involves latent heat. From your physics, latent heat is involved in changes of state. For example, if you're to change, I think I'll be explaining it better, but let's fast feed through it here. Latent heat is involved in changes of state so that the state of the reagents and products affect the enthalpy of reaction. Combination of hydrogen and oxygen form liquid water at 25 at atmospheric pressure evolves to 86 Kelvin, kilojoules per mole. Look at this. So when 2 grams of hydrogen are burnt above 100, less heat is given out. When you burn hydrogen in oxygen, form gaseous water. Okay? And you're using 2 grams of hydrogen. Then you give off less heat. And then in the previous reaction, we have seen that, oh, I don't know, I didn't give the reaction. That was a problem. But the difference, the observed difference is due to heat of vaporization of 1 mole of water. Heat of vaporization is latent heat. The other factor is allotropic modification. Look at this. Rhombic sulfur and monoclinic sulfur can both undergo combustion, form sulfur dioxide. But when you use rhombic sulfur, the heat given out here is lower than the heat given out with monoclinic sulfur. So that shows that allotropic change in allotropy, all allotropic modifications affect the enthalpy change. So the enthalpy change involved in conversion of one allotrope to another is there always. A particular example of an element used in reaction affects the enthalpy of reaction. Now in your notes, for those I will provide with the notes, you will read about a calorimeter. These are very important things, but I won't go through their details here. You read about a calorimeter. You read about the most common calorimeters used in laboratory experiments, which include a coffee cup calorimeter and a bomb calorimeter. You read about heat capacity of a calorimeter and an experiment to determine the heat capacity of a simple calorimeter. We are ending at 10:45. Let me hope I'm not consuming a lot of your data. Unexpectedly, people think Zoom loses a lot of data, but Zoom doesn't use a lot of data. I've experienced that. I'll continue telling you that my WhatsApp number, in case you want to contact me and attend more lessons, is 0753 24 70 98. And then my M10 is 0782 60 10 38. You can contact me on any of the 2 numbers. I'll respond immediately. For these lessons, we can talk and then we see how you can attend them. More of these things I'm talking about are also in our books which we have written. There is the physical book called Demystifying Physical Chemistry, which we are currently delivering countrywide. Many people have used that book and can testify for how far it has helped them pass chemistry. Then there is Demystifying Inorganic Chemistry. We also have Demystifying Organic Chemistry in the progress, still under process of being written. If there is there any question up to where we are now? If there isn't a question, then I can proceed. I see Benjamin is unmute. Are you trying to, do you have something you're trying to say, Benjamin?
No, I'm getting your point.
Okay. So enthalpy of formation is now a new thing we want to look at. What is enthalpy of formation of a compound? That's the heat change that occurs when 1 mole of a compound is formed from its constituent elements in their standard states. I want you to know the difference between enthalpy of formation and standard enthalpy of formation. The moment you add the word standard, the definition changes. And you should know the difference between the two. So enthalpy of formation of a compound is the heat change that occurs when 1 mole of the compound is formed from its constituent elements. For example, if I'm talking of a compound, maybe carbon dioxide, its enthalpy of formation of carbon dioxide will be the heat change that occurs when 1 mole of carbon dioxide is formed from solid carbon, that is carbon in its standard state, and gaseous oxygen. So that's oxygen in its standard state. Are we together? The enthalpy change that occurs when 1 mole of a compound is formed from its constituent elements in their standard states. So when enthalpy of formation is determined under standard conditions, then it becomes standard enthalpy of formation, denoted by delta F HF theta. By definition, what is standard enthalpy of formation? Somebody can read for us.
The standard enthalpy of formation of a compound is the heat change that occurs when 1 mole of the compound is formed from its elements in their normal states at 298 Kelvin and 1 atmosphere.
Very good. So the moment the word standard is added there, this definition changes and it becomes the enthalpy change that occurs when 1 mole of the compound is formed from its elements in their normal states at 298 Kelvin and 1 atmosphere. Just give me a minute, not even a minute, a few seconds. I plug in my device. It has a low power supply. It's almost disconnecting. So I'm plugging it in just a second and then we proceed. Yeah, it's now plugged in, so we can proceed. So enthalpy of formation can be negative or positive. When enthalpy of formation is negative, then it is exothermic, heat is given out. And when enthalpy of formation is positive, that means it's endothermic and heat is absorbed, as shown in that slide there. How do we predict the relative stability of formation of compounds using enthalpy of formation?
Master, I have a question.
Yes. You can ask, please.
When we were defining the standard enthalpy of formation, okay, let's say the question was like this. Carbon and oxygen react to form carbon dioxide. Then they said, what is meant by the term standard enthalpy of formation? What if I say standard enthalpy of formation is the heat change that occurs when 1 mole of solid carbon reacts with 1 mole, when 1 mole of carbon dioxide is formed from 1 mole of solid carbon and 1 mole, wait, I'm sorry.
It will be,
what if I say,
you use carbon monoxide, carbon is combining with oxygen from carbon monoxide.
Yes.
Yeah, I think your thing will come out.
So I would say, is the heat change that occurs when 1 mole of gaseous carbon dioxide is formed from carbon and oxygen in their standard states. Instead of saying that this is the heat change that occurs when 1 mole of a substance is formed from its elements in their standard states.
I think that's better because they have specified the reaction. When you see such a question, in case a reaction is specified, then you also must be specific. Thank you for coming up with that. Let me go back to one of the slides we had here. They can ask you to define enthalpy of formation of sulfur dioxide. Let's use this reaction here. We can say this is the enthalpy change that occurs when 1 mole of sulfur dioxide is formed from 1 mole of solid sulfur and 1 mole of oxygen gas at 298 Kelvin and 1 atmosphere. Are we together?
Yes, we are.
Then maybe if we are using this other reaction here, there is another reaction we had. This one here, it involved the formation of hydrogen iodide. This one here, they can ask you to define enthalpy of formation of hydrogen iodide. By the way, is this equation showing enthalpy of formation? Can somebody think and tell me, is this enthalpy of formation? Hello? Yes. Margarita.
No, that's not enthalpy.
Okay, now somebody had given me a call here. That's why I had muted myself. So I wasn't hearing what you are saying. I asked you a question. Is this reaction showing enthalpy of formation? I want you to hear, to tell me. Yes, Samantha, you're saying something. Samantha is quiet.
It's because
all right, that reaction, for your information, it isn't showing enthalpy of formation. Because we have just said, yes, Okot, you're saying something.
Sir.
Yes. So this reaction is not showing enthalpy of formation because it violates the definition. We said enthalpy of formation is the heat change.
Yeah, that reaction.
We said enthalpy of reaction is the heat change that occurs when 1 mole of a compound. In this case, we are having 2 moles, so this is not enthalpy of formation. Then secondly, the iodine here is not in its standard state. Iodine is a solid at room temperature. It's a solid at standard temperature. The moment you see it is a gas, then that can't be correctly called enthalpy of formation. When does it become enthalpy of formation? When this is strictly 1 mole. This should be 1, and that means to balance this equation, we shall have a half here and a half here, such that it's a half hydrogen to form 1 hydrogen atom, and then a half iodine to form 1 hydrogen atom, and then we shall then have 1 mole here. I think you're getting me now clearly.
yes.
Okay?
Yes, we are getting.
Yeah, you know these things when you don't.
We are getting you clearly.
Now, we can proceed back to where we were. In 10 minutes, I'm concluding the lesson. Whenever you're disconnected, please just connect in back. You'll always be allowed in. I know network can disturb in some areas. So we can predict the stability of a compound, you can predict the stability of a compound by knowing its enthalpy of reaction. Okay? For example, we are saying that when a compound reacts, when a compound is formed exothermically, in other words, when a compound is formed with giving out heat, then that compound is more stable and less reactive. Can you see? I think this isn't confusing. The compound is more stable and less reactive. When we form a compound, and when it is formed, there is heat given out, then that compound is more stable. In other words, if the enthalpy of formation is exothermic, that compound is more stable and less reactive. Then when a compound is formed, with absorption of heat, when a compound is formed endothermically, then that compound is less stable and very reactive. So when a compound is formed with absorption of heat, that compound is less stable and very reactive. Luachi. To form it, it requires absorption of heat. Heat must be applied so that the compound is formed. So that compound now becomes less stable and very reactive because it is formed by absorption of heat. Now, the standard enthalpy of formation of elements, their standard states is conventionally taken as 0. What do I mean by this? If we are forming elements, not compounds, but elements like potassium, sodium, oxygen is an element, sulfur is an element, though they're atomic, chlorine is an element. All those elements, if they are formed in their standard states, then their enthalpy of formation is arbitrarily taken to be 0 kilojoules, 0.00 kilojoules per mole. So this ends the lesson. Let's look at this. The table below shows some compounds. Unfortunately, Joseph, you have arrived when we are ending the lesson. We are almost ending the lesson. So Joseph, you're welcome, but you have arrived. So the table below shows some compounds, equations, and their enthalpies of formation. Pierre Joseph, you're welcome. So the table below shows some compounds, equations, and their enthalpies of formation. Their stability can be predicted using values for enthalpy of formation. Also note that all the equations show 1 mole of compound being formed. What you notice here is that in each case we are forming 1 mole of a compound, right? Is everybody seeing that? In each case we are forming 1 mole of a compound, right?
Yes. Yes.
So if we are forming 1 mole of a compound, these equations very well bring out the idea of enthalpy of formation, right? Now you look at sodium chloride first, and I will have to pose a question here. The question I'm posing is this question: is sodium chloride a stable compound or unstable compound? According to that table, is sodium chloride a stable compound or an unstable compound?
It's a stable compound.
Stable compound.
It is a stable compound. Why is it stable, Semanda?
Because it formed by giving out heat.
Very good. So sodium chloride is a stable compound because according to the values here, its enthalpy of formation is exothermic. It's formed with evolution of heat. Now, can somebody define for me, or quote, can you define for me enthalpy of formation of nitrogen monoxide? By definition, how can you define enthalpy of formation of nitrogen monoxide?
This is the heat change that occurs when 1 mole of gaseous nitrogen monoxide is formed from gaseous nitrogen and gaseous oxygen at standard conditions of temperature 298 Kelvin and pressure 1 atmosphere.
That's excellent. So that's a very superb and a very good definition. It's elaborate. So in case the reaction is specified and then they tell you to define the enthalpy formation of such a compound, you have to specify the states, the standard states of the compound. For example, enthalpy formation of aluminum oxide will be defined as the enthalpy change. Actually, in this case, you can even be more specific because there is a negative here. So you become more specific and say the heat evolved. The heat evolved when 1 mole of solid aluminum oxide, over aluminum oxide in its standard state, is formed from aluminum and oxygen in their standard states at 298 Kelvin and 1 atmosphere. Then I can pose another question. My question goes like this. If my question says that hydrogen chloride is formed from hydrogen and chlorine by the equation shown below, the heat evolved is negative 271.1. Then I ask you to explain what's meant by the enthalpy change for the reaction is negative 271.1. Who can explain that? Explain what is meant by the enthalpy change for the reaction. I've given you this equation, balanced, then I ask you to explain what's meant by the enthalpy change for the reaction is negative 271.1. What will be your approach to such a question and what answer will you give me?
I would say,
I think Okota has tried so many questions. Can somebody else try that question? Benjamin, are you still there? Okay, Okot, you can go ahead. How would you explain what's meant by the term enthalpy of the reaction is negative 271.1? What will it signify?
it signifies that during the formation of 1 mole of hydrogen fluoride from
in its standard state,
hydrogen gas and fluorine in its standard state, 271.1 kilojoules of heat energy is released.
Very good. So that will signify that when 1 mole of hydrogen chloride in its standard state, in this case the liquid state, is formed from gaseous fluorine and gaseous hydrogen in their standard states at 298 Kelvin and 1 atmosphere, 271.1 kilojoules of heat are involved. So this marks the end of today's lesson. I want to hear from you and get feedback from you about the lesson and be ambassadors for other people to attend these lessons. I know they will enjoy them. I chose this topic because I thought most of you have not covered it yet. But if you have covered it, then we shall choose other topics to look at. Then you can also tell me whether we look at physical or organic or inorganic, or we look at, because I chose physical for the first point because it is a major branch of organic chemistry. It covers 80% of most of our papers. So you can comment about the lessons, give me feedback by chatting or talking, and then I can end the lesson in a few minutes.
The lesson was not bad, but I had internet connections which are not good.
Oh, you had a problem with the internet. So to enjoy these lessons, best must always find a place which is a bit quiet and has a stable internet. The moment your internet is very stable, then you can't be disturbed.
According to me, the lesson generally was conducted very well, especially elaborate how to handle
So the lesson finally comes to an end. See you next time. You can contact me further. Notes will be sent to only those who have attended the lesson and subscribed monthly to the lessons. Nice time.
Okay, thank you. Excuse me.
Yes, please.
You can allow the participants to allow their videos or to put their videos on.
I think the option I had allowed it. Hey, at first I was seeing those who had videos on. I don't know what happened later, but that option was allowed.
Okay.
Maybe I'll check it for the settings next time, but I'd allowed the videos for all of you.
Okay, the lesson was very good. I will contact you. I'm going to contact you for more information.
Okay.
This is Benjamin from Bara.
Okay, Benjamin. Thank you so much.
You're welcome.
I'm now ending the meeting.